Thanks for having us. So today we're going to talk about the Android build system and how you can, we want to tell you a story about how the build system might scale with your growing development needs. But who are we anyway? Here's my young colleague Florian.
And this is Volker.
Yeah, we work for Novoda and work off of the Berlin office.
Yeah.
Okay. So, yeah, what are we going to talk about? So, you probably all know by now that Android has a new shiny build system. Actually, it has been announced 2 years ago already.
Yeah,
right?
Google I/O 2013, I think. Yeah.
2013 already, right? But then it took a while, almost a year, until the first final version was made public. 1.0 was released in December 2014, I think, right?
Yeah.
And yeah, lots of changes there. Not only is the build system completely new, right? But also there's a new IDE now. The default one for Android, it's called Android Studio, right? Who's using Android Studio? I guess all by now,
yeah,
right?
Hopefully.
Hopefully, right? And the interesting part about that is that the Android Studio IDE is tightly coupled with the build system, so that wasn't the case before, right? When we had the still the ARM build system, that was kind of one branch to build, but there was the in-IDE build system as well in Eclipse, and now it's all the same. So it doesn't matter anymore whether you build from the command line or from inside your IDE, which is great, so because it makes your build more reliable, and also the new build system hopefully allows you to scale your builds a lot better, right? And that's what we're gonna tell you or show you, hopefully, today, right, Flo?
Yep. So yeah, Android build system and all this stuff is quite rough. So we want to approach this talk by, being in the place of a young entrepreneur. And so let's say I have like a really nice idea. So at first I wanted to write a Tinder-like apps for dogs and cats, but actually it already exists. So why not turtles, right? I know it's a niche market, but yeah, let's try it.
Why not? Let's try it, yeah. Sounds promising to me. So we want to take you on a journey how this app might develop, right? So Flo comes up with that great idea, and now let's dive in. And so one disclaimer here, so there's lots of specific slides coming up here, so lots of nitty-gritty details about the build. But the talk itself is not so much about all these details, it's more about showing you the way how to scale up, how to do things, and give you an idea how the build system really scales up. Okay, so let's dive in. Okay. How do you start with your app, Flo? Yeah. How do you start?
Yeah, so just open the IDE, so Android Studio, right? And then, follow the wizard to have a new project, right? So you follow the wizard and then you end up with this specific file. I guess most of you have opened it already. So yeah, it's really declarative. Nothing is really going on. I mean, we don't have any tasks. We don't really know how this works. It's just like declaring stuff. So basically, we apply the plugin, so the Android application plugin.
And why it is a plugin? I mean, we should mention that, right? Because the new build system is built on Gradle, and the Gradle is a build system that's actually, working with any domain. You can build any software projects with that, right? Or many domains, and the Android build system is actually realized as just one plugin into the Gradle build system.
And then so it's just a matter of declaring a few variables. So for our Android app, we want to compile using the SDK version 23. We want to use this build tools version and then other stuff, configuration stuff. So it's really declarative and nothing is really happening there.
Yeah, so we basically describe what we have in our project and there's no tasks, right? Yeah, so it's just declaring what we have. Yeah. And we still don't know what's, what the build system does with it, right? So we just declare what we have. But there's actually a lot more, right? Okay, we've seen the first, let me use the fancy pointer here. So we've seen this one, but all these other files are related to the build system as well in your project, right? So There's the root build file, for instance, root-build.gradle. Then there is the Gradle directory with the wrapper subdirectory, and that and related are these two files. What is that about?
Okay, so like the Gradle wrapper is a nice touch to all of this, because it's basically is really useful if you want to have a reproducible build. So basically, everyone who is going to work on this project will have the same version of Gradle, and so you will not end up with having this issue like, okay, it works on my machine but doesn't work on yours.
Exactly. So we don't even need to rely on you having Gradle installed, right? So the wrapper takes care of that and downloads the specific version if needed. And what's important here is that this layout should tell you that you have a Gradle multi-project build here, specifically because you have the settings.gradle where the sub-projects are announced. And you have a multi-project here with just one sub-project inside the app folder right here. So we might scale that up, we might introduce more sub-projects, right? But currently there's only this one.
So if you start by using the Gradle-w file executable, you can basically ask them, okay, so what can I do, right? So you can just ask him for all the tasks. And so if you look a bit, you see that you can run a connected Android test, you can install, uninstall, test stuff, assemble, compile, see the dependency maybe.
And what you see here is, there's a lot of things going on, right? There's always a debug and a release version, that's because we have these two build types defined in our build script, and also, it's quite long names, right? So might be a lot of typing. So can we do something about that? Yeah.
So about that, you can call Gradle-w with just the camel case of the name of the task. So for instance, for assemble debug, you could just say AD, so you don't have to type everything. And if there is some name clash, you can always be more precise, like assemble D, for instance.
Yeah, exactly. And what you see up here is that we've pulled in a little tool already. Here's the link. It's called Github, and it's a little script actually available at GitHub that just helps you to avoid these clunky /Gradle-w typing. So it makes it a bit nicer. And also the good part is that that would work if you are currently in a subdirectory, so it kind of moves up the directory structure and finds the right wrapper script to use, right? So nice little utility, and
really useful when you are lost inside your sub projects and you want to just Gradle something. And then what we see here, that you can also run multiple tasks. One after another,
so you're not limited to just one task here on the command line. You can just put multiple ones. But what I'm missing here is some, there's a lot of things going on, but there's actually no run task here, right? It's a bit odd, because in Android Studio there's a button up there, and I press the button and my application gets run on a connected device, right away. So how would I do that from the command line? Obviously there is no default way to do it via Gradle.
So first plugin then.
If it's not there by default, Gradle has this great concept of extensibility. The whole Android build system is just a plugin into Gradle. So of course we can plug in our own stuff. So let's do that in this example here, right?
So here we just pull this. This plugin, so it's the Android command plugin that is made by Novoda, and it's open source. You can check out the code, do some PR, and it's just a thin wrapper around ADB, and it's just a matter of adding a dependency for this plugin and then apply the plugin, and then you have a lot of new tasks that you can use. So here, for instance, you can use GW run and run the debug build.
Yeah, exactly. So you see in the root build script, you define the dependency of your build script, and then in your Android-specific build script here, you just apply the plugin the same way you do apply the Android plugin, right? Nice, and then we have the run task. Great. Yeah.
So dependency, right?
Okay, now back to the turtle business, right? That's what we are going to try here.
So I've created my project, and then, like most developers, you just want to concentrate on the actual content of your app and not like rewriting everything and reinventing the wheel when there is really nice libraries out there. So yeah, Gradle can also handle dependencies. So yeah, you can, for instance, here we use Guava, and we use some test library like JUnit and Mockito.
Right, so Gradle comes with the concept of dependency scopes, right? And these are, you all know them, right? Because these are there by default, they are defined by the Java-based plugin already. But sometimes we have more specific needs, right? We have heard that in a keynote already. There was a mentioning of Dagger 2, for instance. So annotation processing libraries that generate code at compile time, and we need these libraries only when the compiler runs, but not for the runtime. And this is not supported because everything you put onto the compile dependency ends up in your APK.
And that's something you don't want, right? You want an APK that is as small as possible.
Exactly. So anything we can do about that? Of course. Plugins. Awesome. Next plugin here, it's called the Android APT plugin, and it provides a custom scope. It's called APT, of course, and then you can, for instance, depend on Dagger nicely.
Right? Yeah, so start doing my app, and then I want to have a paid and a free version, right? So maybe in the paid version, I would want to have some kind of license verification, and maybe in the free version, I want to have some ads.
Exactly.
But we don't want to have this dependency inside the other version of our app. So Gradle comes also with this thing, so you can have dependency scope that are dependent of your version.
Exactly, it's called flavor dependent, right? So we could define a paid flavor in this case, and then depend, just let the paid flavor depend on some project we might define, right? And here you also see that we have a dependency now on another project. So here we say, okay, we have a project that deals with the license validation. Yeah. Okay, cool. So how's your project going now? You pulled in all the good stuff?
Yeah. But maybe too much good stuff, right? My APK is like really big.
Okay, so we're starting getting stuff like this. Who of you has seen that screen on her phone? Yeah, a few, not too many. So
maybe your phone is too old, right?
Maybe my phone. Sorry, I'm just too cheap on phones, maybe. Anyway, it's from my phone actually, and yeah, I didn't quite like that. It seems that all the APKs get bigger and bigger all over the time, and just be aware that this might be the consequence of having lots of bloated APKs on your device. So try to throw stuff away that you don't actually need for your application. And of course, we've seen it or heard about it in a keynote. Prograd is a great tool to do so. Yeah, so let's use it. And it's actually quite easy, right? There's just two flags to.
Yeah, so it's just a matter of enabling minify, which will shrink your code. And the interesting thing is that you can also shrink the resources. So every resources that is not used in libraries will be removed as well. The issue with that is that sometimes Prograd is maybe too intelligent and will remove stuff you actually need. So that's why you can always define stuff you don't want to be removed in the Prograd specific files.
Yeah, exactly. So that's always a bit tedious, right, to find out the specific needs for a specific library. Actually, for AARs, there's a way to put the Prograd configuration into the AAR itself. So if you write AAR libraries, maybe you want to make sure that you ship your library with the specific Prograd configuration. Also, we're mostly interested in the shrinking part of Prograd here. If you would be interested in the optimizing part, then there's another default Prograd file you should depend on here. I think it has an additional -optimize in there. Okay. Because that was mentioned in the keynote as well, right? Yeah, great, awesome.
So first version of the app is ready. I want to ship it, right?
Congratulations, yeah. So now it's time to upload it to the Play Store. So.
Yeah. So time to do an archive also, to get it somewhere for later maybe. And yeah, so first custom task, right?
So Gradle has a concept of custom tasks, so you don't need plugins to extend it. You can just write task in your build script as you would with Ant, Ant target, so similar thing, right? Yeah.
So here it's just a task that is of type copy, and so you just have to define the attributes for this task. So here we define that we want to take what's inside this folder and this folder and put it into a new one, and then we want to include this file and this file, and along the way we want to rename it to a proper name so we can know what it's all about. And so for this you can use extra properties in Gradle that you can define here.
Right.
So you can have define version name, for instance, build date.
So this is a nice facility of Gradle. You can just define some properties somewhere, maybe in your root build script, and then all your sub build scripts know about this property, and you can just use it somewhere in your build script. And also maybe worth mentioning is that we have a task of type copy here, and we only configure that. So Gradle has two phases of execution, maybe, or maybe not execution, but when the build runs, there's first the configuration phase, and then there's an execution phase. And all this logic here is needed to configure the task, not actually to run it. So when the task gets run, then actually the basic run functionality is defined via this copy task. So we only have to configure it in this case, right?
Yeah.
Okay, awesome, congratulations.
Thank you.
So first version is on the store. All the turtles are happy now, hopefully.
Yeah.
So let's see.
So weirdly enough, I start to get some downloads, and people are excited about the app, and yeah, turtles find love, and everything's great.
So we've basically proved that the concept works, right? And now we want to put some serious development behind it.
Yeah, we start to have a team of developers. I'm not the only one anymore on the app, and so yeah, it's time to scale up.
Yeah, so let's have a look at the weak parts of our current process, right? There might be a few, I'm not sure. So of course we only have the Android module, so it's all mingled into the one sub project we have there. Then so we might change that, right?
Yeah, because we have a lot of code that isn't actually Android specific, right? We could write other apps, I don't know, an iOS app, a web app that could share some logic and some code with the Android app. So we want to put all this code into a new sub-project.
Yeah. Testing, what about testing? Did you write tests for the app? Maybe a few, right?
Yeah, a few.
So we could do better, and of course we need to support that better.
Yeah.
Then we want to make sure, since we're a team now, how many developers are you planning to put on your project?
Yeah, maybe four or five.
Okay, sounds good. So we need to make sure that the quality is up to, to our standards.
Yeah,
right?
so static analysis tool.
Exactly. And yeah, once we have that, we want to run all that automatically, so we need a server for that. So Jenkins probably, so some continuous integration. And finally, since we have it all automated, it would be great if we could also release just from the CI by pressing the big red button. That would be great, right?
Everything uploaded on Github, on the store and whatnot. Yep.
So let's see if we can get to that.
So yeah, reusing, so as I was saying, we can put all the good stuff that is not related to Android and in a new project, in a new sub-project. So for instance, let's call it core, but we could have called it, I don't know, model or something. So it's just a matter of initiating a new Gradle project. So in this case, a Java library. And then now our main app project depends on this. So we need to add a dependency in our app build Gradle. And of course, we need to include this new sub-project into, our global project. So in the settings.gradle, we could just.
So now we have a Gradle multi-project, which we had from the start, right? But now it has two modules, right? We added a core module here, and of course, also we move over a lot of code, all the turtle domain modeling thingies and whatnot, all the things that are not Android dependent, we move over into the core project, right? So there's quite some code now, and maybe that needs some special care now as well, right? For instance, annotation processing. We've mentioned there's a plugin for Android to make that work, but of course we would also like to make that work in a pure Java project and plug in again. There's another one, and then we can use stuff like auto value, for instance. There's some minor quirks still with auto value because it comes as one library, so it's not separated into the runtime and the compile time dependencies. But for runtime, I mean, you basically only need 2 annotations, I think, so it's easy to just move the annotations out and then put auto value on the annotation processor path.
And so yeah, we might want to fiddle a bit with our core module and maybe write some clients to test it.
So while we're at it, right, why not introduce another script module? Right? Because we've seen all the scripting stuff is quite handy because it's not so verbose as writing Java code. So let's pull in another Groovy module.
Yeah, in this case, a Groovy module.
Yeah. So it's easy to create like this. Maybe it's also possible from Android Studio, I'm not sure.
Probably.
You can create a Java module via that, I know, but I'm not sure about Groovy. Yeah, same thing. So we need a dependency here. So this project depends on core as well because we want to test drive the core stuff via our script module here. And then we have to add it again to the settings. Right? And yeah, what might that do? Here's a little example what that could look like. So you could write little scripts like maybe you have a user operation that pulls down some user data from some server, and then you can write this kind of exploratory scripts here.
So you can see what's going on and if you have the right data and how the data are displayed.
Right. So you can just test drive your modeling and backend APIs and whatnot. So might be handy to have that. Right? Okay.
So yeah, we also want to reduce duplication. So for instance, if you use the shortcut in Android Studio to get your build.gradle file, you could end up, so right now we have 3 sub-projects plus the build.gradle which is at the root. So you will end up with 4 build.gradle and yeah, you always end up picking the wrong one and modifying the wrong one, why it doesn't work. So a simple 3-line fix for this is to rename all the build.gradle using the project name, for instance.
Yeah, right. This looks nice. So it's probably easier to find than the right one. Okay, cool. Tests, yeah. Now it gets interesting because in the Android module we have a test folder and we have an Android test folder, right? So we can separate nicely between the JUnit test and the device tests, and of course we want that for our Java module as well, the core module that we just created. And it's quite easy to do that because Gradle has a concept of source sets and you can define your own, and of course we can add another one. In this case it's called integration test, and we just specify where to find the sources, resources, class paths, whatnot, and then we define another custom task here. We call it integration test, and this time it's of type test, and that makes sure that when we run this task, we just run the integration tests that live under this specific integration test source folder. So same functionality as we have with Android tests in our Android module. So yeah, it's quite nice.
And so yeah, with all these good libraries we have, we want to, it's kind of hard to keep up, like, oh, today there's a new version, tomorrow there's a new version for this one, So, new plugin. So this one will add simple task, dependency updates, and you can just run it, and it will tell you which library can be updated. So it's quite nice to keep up with all these updates, and you also get a free a report for free. Yeah, so quite nice too.
Yeah, it's quite nice, right? Because lots of manual work to keep up with all the ever-changing versions of your dependencies. Great, nice. Yeah, code quality, exactly. So, of course, we want to make sure that our code is in style, let's put it this way. So there are the usual tools to use, like check style, find bugs, PMD.
Yep.
And they are actually supported out of the box by Gradle. And it all works nicely in our core module, because this is a pure Java module, but it doesn't work quite as nicely in Android world yet. Maybe that changes, I'm not sure. But for now, you have to configure these tasks manually. So that means that you can use the type check style that's there, because Gradle provides it, but you have to configure it, giving it the sources, giving it the right class path and whatnot. And since we have to do it anyway here, to define a check style main, in this case, we can even tweak it a little and show you how you can customize these tasks. In this case, we use some project, what's it called? Gradle properties, right? Yeah. So in this case, we just use fail fast on error. And that means in some situations, we want to run all the check style tasks and maybe find bugs, PMD, whatnot. Yeah. But sometimes we want to fail fast. If we are in fixing mode, it's good to give us the first error so we can look at it and fix it faster. But if we run on a CI, we just want to run it all and get a full report, right? Yeah. So we need to go a bit faster, but then it will looks like this on the command line. So you just define -P to define the property, and then it will set it to true. There's also a way to nicely, because the report is in XML, which is not really human readable. So you can use end tasks that are supported out of the box by Gradle, and then it will just transform nicely the XML into HTML, which is more readable. Okay, so, great. Yeah, awesome. So yeah, here at Novoda we use only Jenkins. So yeah, Jenkins, you can. The nice thing is you can run tasks, and that will not do the same thing if it's on the CI or not. So to check that, you can just check if an environment variable is there or not. So in this case, build number, for instance. Yeah, for instance, we've just seen that with the fail fast on error. Of course, that might be a property that could depend on this Jenkins thing here, because on a CI, you probably want to create a full report. Locally, maybe not, right? Yeah. So that might be a candidate for mapping it to this system environment property here. So yeah, another little quirk. So when you use the CI, you update all your local stuff, and then you push it to the CI, and then it breaks because you don't have the latest version. So a really nice plugin that will do automatically the downloading and the installing on the CI, so you don't have to SSH on the CI and then update everything by hand. It will do it automatically. Yeah. So yeah, now we're getting closer to the red button. Yeah, we really want this red button. I mean, a lazy developer is a good developer, right? So you just want to push a button and then it will upload it. Let's recall what we are missing, right? So what would we have? So we need to update the version, right? We need to commit those changes, and then upload to store, and then maybe upload the release to Github. Yeah. Okay. So let's look at version updates first, right? So you need some way to persist your version information. For instance, you could put it in some properties file in the simplest way, like done here, and then you can create a custom class that just enforces your version scheme, so that's able to read that file, increment the version, and write it back to the file. And then you just create a simple task. In this case, what's interesting here is that this task is not configured here, but this is executable logic that we define here. And this is made, the difference is here that we have this double lesser sign. So this is really some execution logic that we put into this task here. But yeah, where would this custom class here, this custom version class, where would that come from, right? So, and there's a nice facility of the Gradle system, so you can create a full Gradle module or sub-project under build source. And in this case, we just create another Groovy project, and we put the version scheme implementation there. So nice and clean, right? So it's nicely separated, and we just use it in our build script like this. Yeah. So then we want to commit. So new libraries, it's a wrapper around Git. And then it's just a matter of adding the new file, adding a nice commit message, and pushing. As easy as this. Yeah. And maybe if you go just here to note again is that we use the extra properties again for that, right? So that we can use the access the Git repo stuff outside then later on. Okay.
Yeah, sure. And then, yeah, we want to, so GitHub has this nice release thing, so you can always go back and try an older release quite easily. So again,
yeah, it would be great if we could upload that to GitHub, right? GitHub releases, great facility.
Yeah. So
it's easy to do because GitHub has all these nice wrappers around their REST API. So we just use the Java wrapper here. And the implementation might look something like this here, right? So we create a task release to GitHub. You know, it has to implement some Gradle or extend from some Gradle-based task. You know, so we really create our own task now.
So yeah, 5 minutes.
Okay.
So then it's just a matter of like for each variant to configure this task, right?
So now we create a lot of tasks here, right? So for each variant, that means the combination of product flavor and build type, we create a task to upload that, right? And we also put in the ProGuard mapping files because we want to keep them.
And then, yeah, the nice part, publishing to Google Play. So you have to do some things first on the console to get some password and some credentials. But then you can just publish your APK and then everything that goes with it. So a new screenshot, what are the changes, new description.
Okay,
yeah.
so
time for some
that's
tips and tricks.
That's the walkthrough, right?
Yeah.
So I hope we could show you how things scale up when your development scales up, how you can tweak Gradle here and there to do what you wanted to. And now we would continue with some tips and tricks. So it's more like a floating sections. We can stop at any time. Whenever time runs up. So let's just start. You know, one thing, you want to share methods. You just define it in your root build script, like this one here. We defined a method called rules, and then you can reference it in your sub build scripts, which may be nice when you want to decouple physical locations from their usage here, right? So we just define once where we put our rules files up here, and then we just use this indirection in our sub build script, so that may make it easier to reuse stuff or to switch out rules depending on the situation.
Yeah. Yeah, you can also, so this is nice, you can also like define, okay, this is in the extra properties, you can say, okay, this is the Guava library, and then you can just reference it from sub-project. So it's nice if you want to keep up, for instance, the same version across all your sub-project, and even more, you can even define an array of libraries. So for instance, you could have, I don't know, 3 or 4 libraries you always use in every sub-project that are for testing, and then you can just use test compile and then reference these extra properties.
Exactly, yeah. This is nice. Yeah, about build config, you know, you guys all know about the buildconfig.java class that's generated by the build system, right? Traditionally, there was only this one flag, debug, but now with the new build system, they added a lot of, or maybe some data, some constant in it, and can also be used to add your own constants, and you can use it, you can add constants depending on your build type or flavor or combination of both, and that's how you do it. But there's quite some duplication here, right? So if you want to define a log tag, you have to define it up here, and you have to define it down here. And the only thing that's changing is the last bit here, the last string, right? So what you would actually want to look at like is more like this. And actually this is doable in Gradle, because we could just, you know, we can define some little Gradle file where we put in some closure into the extra property again, so that's really a handy thing here to extend Gradle functionality. And then this time we applied that Gradle file, but inside of the build types closure. So here we say to every of the build types, please apply this closure, and we have to give it this delegate so that it knows that it acts on that closure, right?
Yeah, and then
once we have that,
just end up with this nice formatting. Yeah, so auto login. So this is actually really nice. So we worked for quite some time on third-party login. So especially the Facebook one, when every time you test and you test again, you have to, you know, enter the email and then enter the password and then it enter, oh, okay, it works, or no, it doesn't work. So you do like, you log in, I don't know, 20 times a day during this feature, and then you want a way to automate this login. So again, we use the Novoda command plugin, and here it's just a small script that say, okay, on the first input, you just enter this email, then you go down, you enter this password, and then enter, and then done. And you just have to run this task on the Gradle command line, and then you don't have to type any more really long password and really long emails.
Okay, same here for images. So again, command plugin, let's skip that. Library shrinking, how much time do we have left? Time is running out, so even more advanced stuff. So I hope you get the idea. So Gradle really scales up to what you needed to do, right? That's what we wanted to tell you. And if you want to go deeper, then you're right on this track here, because the next talks are looking in more detail to some of the specifics.
And I think the really important thing is that when you develop an Android application and you get frustrated because, I don't know, you do this action or this task 10 times a day, there's probably a way to automate it using Gradle. So I think we have a nice merci slide. So, yeah.
Okay. So, yeah.
Thank you.
Merci.
Can have 10 minutes of Q&A.
Okay. So we have 10 minutes for questions.
Yeah.
So there was just a slide where you mentioned a version object that you can increment, and I didn't really understand. Is that a standard Gradle thing, or is that a library?
No, that's some custom class you could develop, or that we implemented, right? So it would just read in some data and then enforce your version scheme. Like, I mean, maybe you just want to update some number, or maybe you have this 3 major, minor bug fix scheme. So all this stuff you could implement yourself. There's no support of the those.
The question over there. Yeah.
I was very interested in the part of uploading the APK to the Google Play Store. I think we skipped it in the tips and tricks. What's especially interesting is do you also have a solution or tip how to do it for alpha or beta releases or for staged releases?
I don't know too much about the specifics of that plugin actually, but I think you can at least upload the different flavors, and you can upload to beta and to alpha, so that's supported by the plugin. But if you have more specific needs, I'm not sure if that's supported. But we put the link down there, right? So if you want to follow up, it's called, it's by Triple T, and it's called Gradle Play Publisher. It's on GitHub.
Thank you.
Sure.
Anyone? Questions?
Okay.
Well, thank you very much for all these tips.